So some more terminology that we need to be aware of is this idea of being connected or disconnected. So a graph is said to be connected if for any two vertices there's at least one path that connects them. So for example, if we look at these set of vertices, these are all considered connected graphs. Whereas if we look at this graph, that's disconnected because there's no way to get from B over to the C, D, E branch. Or A is by itself, there's no way to get from A to any of the other points. Or here, they're disconnected because A, B, C are separated from D, E, and F. And I'll draw just one more example. You see some problems like this in ALEKS. You got to watch just because the lines cross. In fact, I'll just adjust this one. If it went like this, if this was A and went over to B, these are still disconnected because there's no way to go from A or B into the C, D, E points or vertices. So that goes back to this idea of just because lines cross doesn't mean there's a vertex at either of those two places. So just keep that in mind, what we mean when we say connected and not connected or disconnected graphs. A bridge, that's another term we need to be familiar with. A bridge is example B, E in this case is an example of a bridge because if you took it out, then it makes a disconnected graph. So anytime you have an edge that just goes off to a single vertex and then ends the way it does there with vertex D, then that one's going to be considered a bridge because if you took that out, then D is part of a disconnected graph. And that's kind of what I was saying there. So like that's a bridge, because again, if you took those off, then points A and E would be separated. This one, for example, is not a bridge because if you took it out, then you could still get from B to C. You just have to go around the other way and go through D. So just keep that in mind as we look at these next problems. So here's just one on connected, disconnected, and bridges. So we want to be able to interpret those. So look at this one. Is this one connected or disconnected? If it's connected, then we want to list all the bridges. So first of all, you look at this, and if you look at I and J, that edge that connects I and J, there's no way to get from I or J into that sort of circular shape. So I and J are already disconnected from the rest. So it is not connected. So this one is definitely disconnected. If we move down, same directions, connected, disconnected, or what, and if it is connected, then we list any bridges that we have. So that one is, if you look at everything is connected, so you can get from any point to any of the other points. So that is connected, but there are no bridges, because if you take any one edge out, so there are no bridges. If you take any one edge out, then it doesn't affect your ability to get from one vertex to the other. You just may have to go another direction. This last one is connected again. If you look at that, oops, scoot that down. There we go. it is connected again. So you can see that it's connected, and again, that's because you can get from any vertex to any other vertex by following a path through there. But a bridge would be this one right here. So AB would be a bridge. If you took out BD, that would also be a bridge. If you took out CD, that would also be a bridge. Because, so if you took out this one, AB, then obviously A is disconnected from everything else. If you took out this one, BD, but then left the AB segment in, then that separates A and B from everything else. And if you took out this one right here, CD, then that would just separate C from everything else. But the rest of those edges, and I'll just change colors here. I'll put those in green. If you look at this one, or 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 this one, any of those edges, if you took just one of them out, you would still have those points as connected. So these are all the bridges that exist in that connected graph.